Good afternoon and welcome to our Yorkshire and Humber branch of IIRSM. We are delighted to welcome Dr. Mike Webster to join us today, and he is going to talk us through some exciting things on temporary works. Now, Mike is a chartered engineer, a fellow of the Institution of Civil Engineers and a fellow of the Institution of Structural Engineers, and has written over 40 published reports and papers. So I can't think of anyone better to take us through the lessons learned from temporary works incidents. Now, Mike has suggested that you are able to ask questions as we go through this session. So either just raise your virtual hand, you'll see that on your toolbar, and then we will have somebody bring you off mute, or you can pop that in the chat and I'll keep an eye out for that and I'll ask Mike as we go through. So Mike, I'll hand over to you. Thank you very much.
Right. Thanks, Heather, and thanks for inviting me along today. And just a brief introduction following on from what Heather said. These days, I spend a lot of time doing expert witness work and also advisory work where things have gone wrong. So as part of that, I tend to see a lot of things that go wrong, including collapses and other problems with temporary works. And so these are sorts of things that would be touching on today. And it will be split into 4 sections. First of all, covering failures of temporary works, then failures where temporary works should have been used, something I find sort of far too common, incidents where there's been near misses, and then finally incidents where temporary works have been a bit more extensive and expensive than they should have been due to permanent work design decisions. And one of the things just to note up front is actually it's quite difficult to find detailed information in the public domain on these sorts of incidents. So I've had to use information from a range of countries over and above the UK. And in those cases where I've been involved as an expert, I'm limited to speaking about what details are in the public domain. So again, if I put some of that up, the information perhaps might not be as extensive as we would like it to be. But just before going into some of the case studies, I thought this was quite useful to look at. This was from the Bragg report, which was report 50 years ago into false work collapses that led to BS 5975. And one of their conclusions was each failure has 2 elements: the technical cause which led to the collapse and the procedural errors which allowed the faults to occur and go untested and uncorrected. And you'll see these coming through each of the case studies as we go through them. Now, the first one, talk about 3 case studies of failures of temporary works, and then I'll stop at the end of this section in case there's any questions from yourselves. So the first one was a 40-meter high scaffold in Milton Keynes that collapsed in April 2006, leading to injuries to 3 workers. Unfortunately, it wasn't a designed scaffold. It was based on a standard scaffold and erected to a height and width much greater than you'd expect for a standard scaffold, a sort of TG20 type scaffold.
Sorry,
It
Mike.
was
Can I just
independent.
interrupt? Sorry, Mike, because I'm just not seeing your slides at the moment.
Oh, that's
Not showing. I know we had them open just before we opened.
I can see them.
Oh, not coming up for me at all. Oh, Joe can see them as well. Brilliant. It is literally just my Zoom playing up. I am ever so sorry, everybody else. I'll be quiet again and see what's wrong with my Zoom.
Better to think you've got a problem and not have one than to think you have and you have.
yes, the wonders of modern technology. And There was a variety of problems with this scaffolding. Although it was independent, it wasn't tied or braced properly, it wasn't inspected properly, no real drawings. And then one of the key problems was unauthorized change. And there was a loading tower at the right-hand side, and I've got some photos in the next slide, and that served a couple of purposes, contributed to the overall stability, um, made sure that the load carrying capacity was within the tower. The tower was used to put pallets on, and because of that, it was largely safe. If you look at these diagrams here, you can see where the loading tower would have been in the previous photos, and there's just an indicative picture of a pallet of bricks being loaded there. They would then be taken from the loading tower onto the main scaffold. And this loading tower was designed for 4.7 kilonewton per meter squared, which was sufficient for the pallets of bricks. Unfortunately, when the loading tower was taken away, loading still carried on, and those pallets were put on something that was designed for around half of the loading tower, 2.5 kilonewton per meter squared, hence why it was overloaded, and you can see the collapse in the previous photo where the right hand side largely disappeared. So it gets a combination of control, unauthorized changes, not following what BS 5975 would require. The second one to talk about today is a collapse of sort of scaffold supports in a concrete building in Rotterdam in 2010. And this was a sort of hybrid precast and in situ concrete construction. The main beams were in situ concrete, but they had precast slabs spanning into them. And before the main in situ beams were completed in place, they had to support temporarily the precast slabs. And you can see some of the support to the bottom of the drawing, sorry, photo on the right here. And what happened during the casting of the floor, the temporary propping structure collapsed, resulting in 5 injuries. And the detailed investigation that the Dutch authorities did indicated there was no stability calculations, and the bracing had been emitted in one direction. And although that had been noticed, there was no clarity and responsibility. So it meant that although someone had seen it, they didn't bring it up, they didn't take any action. And there's just a couple of photos that are in the investigation report. You can see here in the longitudinal direction going into the page, there's actually no bracing between the vertical members, whereas you can see some bracing in the lateral direction. And from the report, it turns out that the people who assembled it weren't aware of the dangers of unbraced scaffoldings. And then here you can see that the vertical members were footed outside the slab, which meant an awful lot of the load was taken in the vertical members rather than going through the slab. And you can see on the right hand drawing here, sort of bowing of the vertical members under the load. And you can see here we've got an offset junction that would have taken an awful lot of bending and shear stress from the level below that you wouldn't expect a connection like this to have to take. So again, a combination of the design left out elements. It wasn't appreciated on site. It was spotted by some on site who didn't flag up the issue. And then the third one, some of you might be familiar with. It's the Nickel Highway collapse that occurred in April 2004. It was a cut and cover tunnel in Singapore that was 20-meter wide, 33 meters deep. And there's a section through it in the top diagram on this slide. The collapse was actually at the 9th level down. Unfortunately, 4 died. Again, it was a combination of sort of multiple design and construction errors. I've got a few more slides showing sort of detailed photos what went wrong, but in summary, the design had used the wrong method for undrained soils in the finite element analysis, which ended up overestimating the soil strength, underestimating the loads, giving an undesigned diaphragm wall. The stiffeners were inadequate because the temporary works designer had misinterpreted BS 5950 for steelwork. There'd been some previous buckling of stiffeners, so they changed to a C-channel section, which is less ductile, gives less warning of failure. And then in construction, load spreading splays were left out, and it wasn't picked up during routine supervision inspection. And got a few more details here. This slide shows what was happening 2 months before the collapse. You can see at the end where this member comes in, the longitudinal strut comes into the whaler. Because there's a heavy concentration of load there, they've put 2 stiffeners there to stiffen the web. These would seem to be buckling, and the assumption was that more load was being taken into the whaler than anticipated. So the reaction to that was to replace those vertical stiffeners shown in the previous slide with sort of C-shaped channels that are shown in yellow on this slide. The trouble is no one had experience of using them with stiffeners. It seemed like a good idea, but they didn't have the experience and didn't appreciate that although the capacity increased marginally, the ductility, that warning of failure, was reduced considerably because there tends to more of an element of sway failure whereby the channels would move sideways. And the other problem was the connection of the whaler with the C channel, and the designers had got the bearing length wrong and the effective length of the web. What should happen is if you've got the web taking a lot of load, you want it at an effective length as low as possible so that it's stiffer. And what we should have had is a 65mm assumed width rather than a 400 assumed width. And the web shown in the bottom here as sort of curved should have been taken as 1.2 times the length instead of 0.7. And results of this, for those that are familiar with steelwork calculation, is that it's overestimated the load carrying capacity of the connection and less stiffeners were provided than actually needed. And then when it came to the site work, not only had we got the design problems here, but there was an intention to put in these splays, which were the diagonals 45 degrees shown in the top diagram here. And they would have taken some of the load from these struts, put it into the whaler. Without these splays there, the loads were going straight down the struts here into the C sections here, which you can see have swayed over a bit, and then into the whaler. So it meant the connections were carrying sort of 100% of the strut load instead of 2/3. There was no redundancy anywhere else for the load to go, which meant that when a strut fails, the neighbour's unable to take the load. And because, going back to the first slide, we've got an understrength diaphragm wall, which was unable to distribute the load, then that's when the failure occurred. So a combination of design and construction issues that weren't properly spotted either in design check-in or in the construction. And I'm just about to start a new section now, so I thought I'd check in case anybody's got any questions.
I can see a question from Max in the chat over there, and he's asking, are you promoting the updates to the standards, including BS 5975, which was updated in February this year? I think you make reference to that later on. If you got any comment on the standard BS 5975 at this particular moment?
Yeah, and to say, I've got a few comments later. I think that the BS 5975 is actually, it's made quite a difference over the last 50 years in terms of sort of improving the management of temporary works. And I think one of the things that you'll see through the case studies here is if BS 5975 had been properly applied, both to the design and the construction checks, then a lot of these wouldn't have happened. They'd have been spotted either at the design stage or on site, or they wouldn't have been loaded because somebody had seen there was a problem. So I'm quite a big fan of BS 5975. I think in some way, because of 5975, temporary works design is actually better controlled than permanent works design because the procedures are there and are adopted. But I'll touch on 5975, a few other points on the way through.
Okay, that's fabulous. Max also asked, do you think that the Building Safety Act has had any impact on temporary works design?
Probably not. I think because of the definition of the Building Safety Act, it's almost sort of tangential to temporary works, isn't it? It's about sort of building works rather than construction works. And there might be some issues, right? For instance, if you're replacing cladding, you'll need a lot of temporary works in terms of scaffolding. But then that would largely be a construction CDM issue more so than a building safety issue. And I know it's something that's been discussed in the Temporary Works Forum over the last couple of months with people trying to establish the extent of the impact of Building Safety Act on temporary works. And it's, I think it is probably there for anyone to have a look at in the public domain on the Temporary Works Forum website. But I don't think, or the view was that it wasn't having a great deal of impact, largely because it would be covered by construction work and CDM.
Okay. Max, would you like to expand on your question? I can see you've just added another line there. If you want to explain that, that's quite all right. If you put your virtual hand up, then Julie should be able to unmute your microphone. I can see it just went up there. I don't know whether Julie can unmute Let me also just see if I can.
Sorry, that was my. Can you pop your hand up again? Sorry, I lost you. I muted the wrong person. I hand slipped. There we go. Oh, it keeps moving about. That's why. Let me find you in the alphabetical list. Was it who was it, Heather? The one who asked the question.
Max,
It was Max.
sorry, it's
yeah,
just not letting me unmute Max.
time I hover over it, it disappeared. So let me. It just keeps moving. There's something wrong with my system here.
Right, can you hear me now? I'm
There
unmuted.
we go. Thank you,
yeah.
Max. Sorry, it wouldn't
Sorry
let me
about
do that
that.
in my chat.
Yeah, so just to expand on it then, because we've gone through the training here as the organisation, the Building Safety Act 2022 covers all absolute elements of construction and design and its implementation. All law is child to the Act. So it will cover temporary works to the guidance because it's seen as child regulations now. So if you are undertaking highways or any construction with impact buildings and its surroundings, it's any building, not just higher risk and not just cladding. So yes, it will, because it's now live and being enacted, people undertaking things like this will follow designer guidance, but they are other regulations to the new Act. Because I've gone through the training, I now know. So like anything we do as CDM and temporary works, I have to make sure I fulfill the Building Safety Act as well.
No.
Competency, big question. So like we've gone through the, the formers there in the Whaler, perfect example of like misunderstanding legislation or misunderstanding guidance. So they've used the wrong formers and bang, there you go.
I think the key thing is looking at it case by case, and what is there going to be an interaction with the temporary works on the permanent building works?
Yes, Mike, it will. Because you're underpinning things like substrates and foundations here, so you cause a building collapse. These are the things that now become more and more of a thing under that banner of competencies. I've got to prove my designers are competent in their understanding. If I'm the primary, if I'm the only contractor on a job, I am the de facto primary. So yeah.
Yeah, so it adds in really another level of it's good if it helps improve the sort of competency with that, gets people to consider.
Yeah, you really got to look really close at like in your case here. So temporary works and competencies, like I have to prove like they were competent in their understanding.
Yeah, so competency plays a huge part in the Building Safety Act as well as under the CDM regulations under the Health and Safety at Work Act as well.
Yeah. So the Health and Safety at Work Act, that's coming this year and into next year, so we get a new one. So in my lifetime at being 50, there it is. So it's all going to come to the fore. So like I've got to do it's called knowledge, skills, and behaviours for designers. So that's perfect examples that Mike's going through here.
Fabulous. Thank you very much.
Yeah, for that. And a few more to come that hopefully will give you some case studies.
Yeah, spot on.
I've just got one more comment from Ahmed, who says the integrity of the construction drawing engineer and the temporary works coordinator as well is also quite important. Okay, thank you for that, Ahmed. Okay, I will let you continue. Thank you very much, Mike.
Right, thanks. And this next set of 3 case studies is something that I perhaps see a bit too frequently. Failures where temporary works should have been used. And the first one, relatively straightforward one, it's a trench 2.4 meters deep. It should be relatively obvious that we need to support a trench of that depth, because one of the big problems is, yes, soil can stand up on its own when it's excavated, but we don't know whether it's going to stand up for 30 minutes, 30 hours, 30 days or not. And there's that level of huge uncertainty, which is why we tend to use either proprietary shoring or battering the sides. And this one, you can see the fines that handed out, 2.6 million for it, and that was nearly 10 years ago. It gives an indication of how serious it's viewed. And I working on a few cases at the moment with unsupported trenches, and unfortunately the message doesn't seem to have fully got over that trenches do need to be supported once you go into this sort of depth. The next one is a large ground beam. It was 23 meters long, 3 meters wide, 2 meters high, and it had upstands at either end that would have been, again, 3 meters by about 2 meters by about 2 meters thick. So a fairly hefty concrete structure that was used to contain any failures of a pressure testing facility. So effectively, if there was a failure, it would almost be like a missile hitting the ends of the wall. And in order to absorb that amount of energy, we've got something of this size. And what you can't see here is that there was 3 layers of T32 reinforcement that was supposed to be sitting on top of the reinforced cage shown in the top slide or top figure. And although there was those 3 layers of T32s, the design included no diagonal bracing or Z-bars or tiebacks or anything like that to provide lateral stability to the cage. And unfortunately, there were 4 workers working inside this tight fit cage. They were pulling across the T32 bars on top, and there was a racking failure. Effectively, the links there went over like a set of dominoes. And the picture you can see at the bottom right of this slide is what happened after the collapse. Unfortunately, those 4 workers were trapped inside the cage under the weight of that steel and died. That, as a result of that and other cases, the Temporary Works Forum has actually put a lot of effort into producing guidance. And over the last 5 years, 2 guidance documents have been published by Temporary Works Forum, one on the sort of procedural side and the other on the technical side. And they're both available for free download on the TWF website. And hopefully, if those sorts of guidance are followed, then we shouldn't have these sorts of incidents. And again, you can see here that not only was the principal contractor fined 200,000, the client was fined as well. The principal contractor's director had 7.5 months suspended jail sentence plus community service and costs. The contractor, the charges were left on file because unfortunately it was their people, or a couple of their directors had died, so there was no one really to be charged with that. The only organisation not prosecuted was the designer. And then I put this one up. It's not what you would call traditional temporary works. It's what I would call just temporary support. These frames you can see sitting in with the openings here and behind the tent, they're actually fairly heavy steel frames that form doors to a gallery. But because of the lack of storage space, both outside the site and within the site itself. 3 frames were left propped against the column here overnight. Those 3 frames weighed 655 kilograms overall, and everyone just thought they'd been strapped to a column. Turns out they hadn't, and unfortunately they ended up falling on a passerby, killing her outright. And I, contractor fined for it, contractor supervisor had 12 months jail sentence, principal contractor site manager 6 months suspended sentence. So just as a reminder, it's even what we might view as fairly minor sort of temporary condition. Just make sure things are restrained or strapped properly. It doesn't actually need much force to stop things like these falling, but equally it doesn't need much force to stop them, or say to start them falling. So just a reminder about simple situations. Right, I'll just stop there just in case there's any questions before we go on to the next section.
Give anybody the opportunity, if you just want to raise your hand to ask any questions at this point. I've not got anybody popping up in the chat. No, I think we're good to continue.
Right.
Mike, thank you very much.
This next category, as we sort of go down the categories of serious, is incidents where there've been near misses. And again, it's quite difficult to get information on these. So what I've relied on is the confidential reporting system on structural safety. And for those of you that aren't familiar, I just put up a quick slide. It's an organisation myself and a variety of others are members of, and what we get is anonymised near miss reports from people in industry. We then review them and put comments, and then it's put on the Cross website for people to look at the reports, and also sent out in quarterly newsletters. But where it's quite useful, if you've got a particular situation you've not come across before, or you're doing risk assessment or planning, it's often worth just clicking on it, the site, having a look, putting in your keywords, and you'll see other people's near misses and the comments that we've put on it. And so it's quite useful just to learn from other people's near misses, get the information into your planning. And equally, if you see something that's a near miss, submit it to Cross. It's all confidential and will all be anonymised. This is one that I took from a Cross report, and it's a long wall, 3.7 meters high. And the way the construction program was designed, the internal wall was always going to be completed before the exterior built envelope was, and cladding on the side was going to be finished. So there was always going to be an element of sort of wind tunneling and wind force on that wall. And the permanent works designer did identify the need for proppering in a risk assessment that they did, but it seems it wasn't set out clearly enough for the contractor to spot, although really the contractor should have questioned it, given a wall of that height with the potential for wind. But it highlights a couple of points that, again, tie in with BS 5975. The permanent works designer needs to highlight risks where temporary loads are going to be more onerous than permanent ones. In this case, the temporary wind load when the wall is exposed. And contractors should also be a bit more aware of the temporary situation and just seek engineering input, or just ask the designer if they've got concerns. This next one, I apologise for lack of photograph, but quite often with cross reports, we don't get the photographs because that would identify the structure. But the issue was that there were columns that were kinked in order to take up less space at higher level than at lower level. And what this kinking of the columns causes is horizontal forces that need to be taken back into the core. And when you've got your final permanent structure, everything's stable, those forces will be taken back into the core. But in the intermediate stage, you need to give some thought as to how those forces can be resisted. And with this, because it was largely a steel structure, but the second floor was post-tensioned in order to give longer spans, the contractor decided to erect the steel first, with the post-tensioned second floor being done later. And the steelworks subcontractor appreciated the issues here, put in temporary bracing to the kinked columns. The main contractor then, for some reason, removed that bracing, presumably in their way, and a bit surprised when told the bracing was still required and it needed to be put in to stop any potential temporary instability. So we get a sort of variety of CDM and BS 5975 issues that the permanent works designer had realized that the second floor was quite key, and so it put in a horizontal force there that needed to be resisted during construction. They thought it was obvious to the contractor. Unfortunately, the main contractor had no temporary works team or temporary works coordinator, so took out the bracing. There really, if it perhaps needed to be more on the permanent works designer's drawing, just identifying there needs to be brace, not sitting there to resist this force. The permanent works designer doesn't necessarily need to design the bracing. They just need to point out bracing is required, so that at least there's a safe method of constructing it. If, however, the contractor changes the method of construction, it's then not the permanent works designer issue if he's unaware of that change, because he's pointed out one potential construction sequence that has now been changed. But because the permanent works designer has pointed out that issue, it's then down to the main contractor to find another way of resisting those horizontal forces during construction. And then the third one is something that goes on quite regularly around the country, where people want to open up the back of their houses and put an extension or put bifold doors on. And here you can just see a sort of bare minimum of propping here, which gives support to the vertical, but there's nothing to resist any sway. There's no bracing here, and it's very difficult to get any sort of props up vertically, which means there'll always be horizontal load. So all it needed was just some simple bracing on these. But again, if people are not familiar with it, then there's just the temptation to think, we just need to take the loads of the walls. And that's come to the end of that section. So just check with you, Heather, whether there's any questions.
If anybody wants to raise your hands and ask any questions, that'd be great. So that last photo on your slide, Mike, made me cringe ever so slightly.
Yes. I suspect there's a lot of that going on that we don't see. It's just someone submitted that to Cross as a near miss.
Yeah, absolutely. And that, again, I was thinking quite a bit about CDM as you were talking there and going through, and obviously domestic properties, they do come under CDM, but often get Yeah, little, people turn a blind eye to them, unfortunately. If, as a role of a principal designer, obviously we're always asking for where's your design risk assessments, even of those temporary works designers. But as a principal designer, or even as a client taking accountability and responsibility, should we be encouraging designers to really design for buildability, to reduce temporary works, to reduce that unnecessary temporary works where we can, perhaps?
Yeah, I think that's quite an important issue, because some people in the temporary works forum, I know, use the sort of comment, the best form of temporary works is no temporary works.
Yeah.
And to actually, if you can design the construction sequence such that parts of the permanent structure are constructed in a sequence that it will actually take some of the load, then that makes life a lot easier. Because the other statistic that often gets bandied around is temporary works are around 40% or so of the cost of construction work. So if you can remove them by design, then it can make it easier to build, it can make it cheaper to build. It just needs a little bit more thought and perhaps integration between permanent work designer and contractor to get that design that's easier to build without extensive temporary works.
That's quite interesting, putting that cost element in there as well, that 40%. That's really interesting. Okay, I don't have any more questions coming through in the chat at this moment. So again, I'll hand back over to yourself.
Right, and the final category is I've called incidents where temporary works have been more extensive or expensive due to permanent works designers. And this probably follows on quite neatly from Heather's question there. The first one here is, I mean, it's a fairly impressive scaffolding structure, a standalone, independent one. But the reason it's standalone is because no ties were permitted in the building because of the render used, the difficulties of patching, no opportunities for through ties as there weren't windows. So we've got this fully buttressed freestanding scaffold. And one of the things I always point out is actually the time, taken to erect scaffolding actually exposes quite a lot of the scaffolders to risk of falls in particular. And this took 4 operatives 7 days to erect, and presumably something similar to take down. And I'm not sure how much it's cost, but it just feels a bit unnecessary, purely because decisions taken in the permanent works design meant that the scaffold couldn't be tied into the building, and so we needed this buttress freestanding scaffold. Another one that to be wary of is integral bridges. They're a good idea because they get rid of bearings and movement joints at piers where the bridge is all built. But a bit like the Dutch structure that I showed on the second slide, essentially what you've got is precast beams that are spanning between in situ concrete diaphragms. So you've got the in situ concrete here and at the two ends, and then you've got the precast beams that span in between. So the precast beams will need to be supported until the concrete in the diaphragms at either end in the middle has reached sufficient strength. And so effectively any temporary works would need to take the weight of the bridge beams. And one of the key things we can see here is that because the foundations stretch out far enough, then you've actually got a decent foundation to put the temporary supports in. And it's just, you can see behind here the props that are holding the precast beams in place and taking the load down into the reinforced concrete foundations that are underneath it. if those foundations hadn't been extending out a reasonable distance, then you would have ended up with almost temporary foundations for the temporary works. So again, it's just a simple thought in the permanent works design. Think about how it's going to be built, and yes, it might take a bit more concrete with slightly larger foundations, but it will save a huge amount of temporary works on site and make it safer to build. And then the final example is an office block structure, and a crawler crane had to be used on the ground floor slab in order to install fairly hefty structural steelwork. Unfortunately, the permanent works designers hadn't considered the construction load case in part of their design. They only looked at the permanent cases. And of course, having a crawler crane going above or tracking on the ground floor slab is a far more substantial load than any of the permanent loads. And as a result, this is why you've got fairly extensive amounts of propping shown here that the contractor has to put in place in order to make sure that the crawler crane could move over the slab to help install the steelwork above. So again, just another one of those things for coordination between permanent works and temporary works design. And then I've just got a couple of slides to end with. First of all, although I use the word in summary, and actually there's quite a lot of bullet points, in fact, all these points have come up on the way through, and actually most of them are covered in BS 5975, and they're the sorts of things that if we'd done them, wouldn't have had the incidents. And one of the most important points is the one at the end about temporary work controls on small sites. We tend to think of temporary works as a sort of full BS 5975 implementation with procedures and temporary works coordinators, supervisors, designers. But actually, HSE has produced what's called a sector implementation minute on its website that suggests for smaller sites, there is a more proportional solution. It doesn't necessarily expect the full-blown BS 5975 implementation, but you need to follow the principles of having a checks design, having hold points in there, having checks. And then just to end on a positive note, and ties in with one of the questions that came up early on about BS 5975, and some thoughts coming from fairly senior people in the temporary works industry that impact of BS 5975, influenced as it was by the Bragg report, has been profound. Since its adoption by the industry, there's been no force work or excavation failures in the UK on the scale of the failures of the early 1960s and 70s. And to go with it, tying in with what I've been saying on the way through, the controls, if complied with, reduce the risk of failure to an acceptably low level, but non-compliance, part or whole, significantly increases the risk of failure. And we've seen that through the case studies presented. Right. Just any questions now? That's the end of the formal presentation.
Thank you, Mike. Would anybody like to put any more questions in the chat or raise your hand? And then we can put those to Mike. I was just checking while we did that. It was interesting what you were saying there about the SMEs and it being proportionate how they apply the BS standard on site, because I was sort of thinking, okay, it's the SMEs that do struggle a little bit with application, that implementation. So it was interesting to hear that you referenced that there towards the end as well.
Yeah, and there's a downloadable document. If you Google HSE sector implementation minute temporary works, there's a document or web page on HSE's website that actually sets down their thinking of how BS 5975 should be applied and what they expect as minimum standards. Because although it's not sort of mandated in any legislation, it's sort of good practice in sort of planning, managing, monitoring, coordinating the risks. And so HSE sets down what it's expected, and what's quite useful is it sets down what it's expecting for small sites over a couple of pages, and it is worth getting that message over to small sites. They don't need to have the full-on procedures. They just need to have a competent design that's checked. They need to have somebody check that it's safe to load or unload, and some of the simple things that perhaps go with scaffolding, like sort of scaff tags and weekly inspections, perhaps introducing those sorts of things for excavations as well.
Yeah, that's a good thought as well. I've just got a question through from Ahmed, who says, looking at the incidents that you have shared, that they were largely related to human factors. So he's asking, how are we to play a role in identifying these errors and bring the construction team back to compliance and an engineering philosophy?
I think that's one of the issues. I'm glad he's recognised that, because it's something that struck me. Being an engineer by background, you tend to think to yourself about the technical issues, what happened with the steel or the concrete. But in reality, the more important question is, why did it happen? And it comes down to human and organizational issues. And a lot of it is down to communication, making sure it's clear who has what responsibility, and people, if they spot something, doing something about it, reporting it back. And I think when you look at things like BS 5975, and it's become a bit more obvious now, but I think in the past it may well have put people off because of its title about permissible stress design of false work. A lot of people could look at that, that's not relevant to me. But actually, the first 40 pages or so is all about those human and organizational issues of procedures, approaches to take, responsibilities to individuals. And it actually sets it down quite clearly for temporary works, what's expected of each of the parties. And what a lot of people don't appreciate, there are actually duties in there for permanent works designers and principal designers in relation to temporary works, as well as the obvious ones for principal contractors, temporary works designers. So and now it's been separated out into two parts. You've got the sort of management procedures as a standalone, and the technical side for design of false work and formwork is a separate document. So one of the things I'd like to see is that document, the part one, be made, or people to be made more aware of it, because it applies to more people than you think, and it is a very good document setting down the procedures. And I did a publication about 3-4 years ago for CIOB on managing temporary works. And I just tried to put what was in the first part of BS 5975 into plain English, so that even those that don't do temporary works for a living can appreciate what's wrong. And just simple things like that, getting more people to read about it, think about it, incorporate it into their company's way of working. That would be good in addressing these human and organizational factors, because a lot of it does come down to people and their organizations, what they do, how they do it, why they do it, and what responsibility they take, and also clarity and communication.
Yeah, absolutely. I've just got Max has just posted a link to the HC website in the chat, so thank you very much, Max. Michael says, on designs for temporary works, can the contractor have his designer design the temporary works?
Yes, and that's quite cool. It tends to depend on the site. Some of the larger tier one contractors will have their own in-house temporary works team because they're doing a lot. Others, the contractors end up using a specialist temporary works consultancy. There's quite a few of them out there. But yeah, it's perfectly reasonable for the contractor designers to do that. They just need to follow the same approach as everyone else in that the temporary works coordinator would prepare a design brief, the design would be done to that, and then BS 5975 specifies a level of check-in that's compatible with the sort of risk level with it. So if it's just something that's out of a manufacturer's catalogue, your own team can do it. But as it starts stepping up to, say, complex scaffold at the side of a railway, then you would need to go for an independent checker outside your organisation. But there's a fairly clear table in there that specifies what level of check is needed for each type of temporary works.
Yes, I've seen that, and it is very, very clear and concise. I was going to quote you there as well. I was like, yeah, it's complex or novel. So then we go for that independence. Okay, I've not had any more questions come through while you've been talking. I think because everybody was so engaged in listening to what you were saying, because it was very, very informative. So thank you very much for that, Mike. Really appreciate it.
Yeah, and thanks for inviting. It's an interesting subject, I think.
It is, absolutely. And it's one of those, I think, that just needs the spotlight shining on it more when we're out on construction sites and when we're in the design team meetings. I think that word temporary has that mental shift where people just think, oh, it's just temporary, so it'll be fine. But it is very, very important. And it is, like you say, one of the lead things that we do need to be contemplating and we do need to be thinking about. So I would like to thank you for that, Mike, and for your time today.
Thanks.
Thank you. For everybody else, thank you for joining us for our webinar today. I hope you found that as interesting as I did. I am pleased to announce that we have been invited to join the North Eastern Cumbria branch meeting on the 20th of October. So it's a legal update from Matthew Brakell at DAC Beechcroft. So he always provides an amazing, very informative update. So I'm quite looking forward to that. So do look out for your emails and make sure you register for that one coming up soon, again on a lunchtime. So thank you all very much for joining.